Hello, in this video we will determine the LINEST value of this dataset with two independent variables. We begin with the LINEST function where we show the full statistics. Uh, we have here the intercept, the slope 1 and slope 2, standard error of intercept, standard error of slope 1, standard error of slope 2, the standard error of estimate, the RSQ or R square, the degrees of freedom, F statistics, residual sum square, and the regression sum of square. We will determine this value using the matrix operation. So we start with the X matrix. So we have the X matrix where you have the first column as 1, second column will be x1, and the third column will be x2. Then we convert this to a square matrix. We multiply by its own transpose, which is now that we have a square matrix, we can do the inverse of this matrix, inverse function. Now we have the inverse function. We can also multiply the transpose of this matrix to the y values. So it is equal to multiply the transpose of this matrix to the y column or the y values. Now that we have this product, we can now multiply the inverse and this matrix, which is equal to this matrix and this matrix. Now we have the coefficients. We have this intercept, slope 1, m1, and the slope 2. Now that we have calculated the slope, we can now calculate the y hat or the y estimate with this matrix. So this is equal to this matrix times the coefficients. Now we have the y estimate or the y hat. Next we have the variance. We calculate this value. We need the variance of the population y. And we also need the population, which is equal to rows of the dataset range. We have a population of 9. Then we calculate the degrees of freedom. We have n minus 3. That's because there are two more independent variables. Used to be n minus 1, but since we have two more independent variables, so it will be n minus 3. So this is equal to n minus 3. Now we calculate also the residual sum square, which is equal to sum x or sum of the square of the difference of y and y hat or the error. So we have 4.599, the residual sum of squares. Next, we calculate the regression sum of square, which is ESS equal to the population times the variance of population Y minus the residual sum of squares. So we have 195, which matches to this, and this matches to this. Next, we calculate the F statistics, which is equal to ESS divided by 2. That's ESS divided by 2. That's because there are two independent variables divided by the standard, which is squared. So we don't have that value yet. So calculate the standard of error squared. So this is equal to square root of RSS divided by the degree of freedom. So that's 0.875, which matches to this. Now we can go back to the F statistics, which is equal to ESS divided by 2 divided by the square of the standard of error of the estimate, which is this to the power 2. And that gives you 127.27, which matches to our calculations. Next, we calculate the R square, which is equal to ESS divided by the population times the variance of the population Y. And that's equal to 0.977, which matches to this. Now we're down to the last three. We start with the standard error of the slope 2, which is equal to the square root of the standard error square times K8. K8 is this one. We have 0.491. Next, we calculate the standard error of the slope 1, which is equal to square root again, standard of error square times J7, which is this. Okay? So 0.682. And the last, standard error times I6, which is this. So equals square root, the standard error square times I6, which is this. That calculates the LINEST function of a dataset with two independent variables.